So let us continue. Previously, because of the problem of the Sony camera, so I stopped there. And about the description, so we need to have the description from the first message. So we have these. Usually we have the request, but right now we have the cookie setting. So we will set cookie. And after that one, we can have the first action. But the further action, we have the cookie along with the request. Then we can have the response. So this is a way to have the setting for the cookie and cookie ID. And a few weeks later, or maybe 1 week later, we have this send request but with the cookie ID along with that. Then we can have the access with the backend using the ID. So we can have the easy way to pass the access. And later we will have a discussion this way, is it safe? But currently we don't care about the security, we care about how to have the simplified procedure by using cookies. Well, so we have comments for HTTP cookies. So additional cookies and privacy. So we want to avoid some maybe lengthy operations. So we want to have cookies. However, how about privacy? It should be well taken care of. So cookies and privacy, possibly we may have the conflict. But currently, we just continue to have the description for cookies. So while we can use cookies, authorization to make it simple. So we have authorization. And because of authorization, so in shopping carts, we will have this as well. And for recommendations, user section step, for example, webmail, and then we can use these. All right. And actually, we have challenges for cookies. How to keep stats. All right, actually we have two endpoints, the sender and receiver. So we have the two endpoints, including the client. So it doesn't mean it's the responsibility of the server only. Actually, we have the possible responsibility for the client and the server simultaneously, and so that we can have the operations of cookies. All right, so this is the comments for cookies. All right, so about cookies, maybe you can think about that one for 1 minute. Because of an online code, so I should really have time to think about that one. So I set 1 minute for you to think about that one, cookies. So maybe you know the details about cookies. Therefore, let me move on to the next one. Actually, the next one talking about the caches. That's correct. The pronunciation of the current word cache, same as CASH, cache. But currently, we don't talk about money, don't talk about cache. So it's web caches. Web caches, we expect to have the proxy server to do something for us, so we have a proxy server. So web caches or proxy servers, here we treat them as the same thing. So we have web caches, and here we have proxy servers. So why we want to have caches? Actually, we have a request from the client, and sometimes within proxy server, do you have some copies? All right, copy of the web. I mean, for example, the website of maybe some files of the website. So if you have those copies and they are fresh enough, is it possible to return those copies to the client? So this is the idea for web caches. Of course, yes, we think it's okay. So we will have the configuration. User configs browser to a point, and then that one serving as the proxy server. And that proxy server will have caches of web. So it will send if object find. So we have the object found there. So we can return the object to the client. Or otherwise, we still need to request the object from the original server. From the original server. Well, so we have the possible situation found. Then we can return. If no, then we still need to send the request, forward the request to the original server. So this is the idea of web caches. You see, originally, of course, we need to have the possible transaction. And so that we have the file or the copies kept at the proxy server. So next time, if anyone else, or maybe it's the client, the original client, and then it can return the copies to the client. So web cache actually act as client and server. Server means we have copies, then something like, oh, okay, I serve as the server, so I can return the copy. Client says, oh, this time no object stored here, and the proxy should send the request to the original server. So we have the two roles of the proxy server, serving as the client and also serving as the server. You see, we have the meaning server. We have the meaning client. All right, client to forward the request to the original server. Server to serve as the representative of the original server. All right, so the two roles are for the proxy server. Well, so how to have the cache or the proxy server? It will be installed by ISP. All right, for example, university, company, residential ISP. And so that you will have the proxy server properly to that you have the possible content. And why we want to have the technique web caching? Because we want to reduce response time. And why? Because cache is closer to the client, so it won't be necessary to request the file from a distant server. And also reduce traffic. What that means, reduce traffic, actually we reduce traffic load. Traffic load send through the access link and sell that traffic load to the original server. So if we expect to have a cache, then we expect to have internet dense with caches. But if so, the performance is okay? No, the performance is poor. It doesn't mean this one is really okay. So we will have some changes. So let us check the following example. Why we want to have a cache? Here we have the setting. The setting for the scenario. Access link rate. So it's 1.54 megabits per second. And the RTT is 2 seconds already. And the size of the object is 100K bits. And the request rate 15 per second. So based on this, then we can have the data rate to the browsers. You see, we have this one. And multiply 15 seconds. So we have these. So then we have the clear description. This one, we have these. Sorry, BPS. B per second, so that's why we have these. So this is the reason for this one. And right now, the utilization. How to have the utilization? We can have this one. LAN, about LAN. So here, this is a LAN. All right, so this is the utilization. LAN utilization. However, for the access link, and currently we have 1.5 megabits per second. And so that this one, we have 0.97. Well, if 0.97, and this is the traffic load. Maybe the second traffic load, and this is traffic load. It's the first traffic load. So like traffic load, so how about the delay in LAN? The delay in LAN is small. And how about link going through, the delay going through access link, extremely large. because of high traffic load if we consider queuing delay. Right? You can check the queuing delay in chapter 1, then you will know if we have a traffic load approaches 1, then we have the extremely large delay. So for this one, then we will have the really large one, and this one small, right? And access link is large. And currently within large, maybe a few minutes. So that's why you see small, we set it to microsecond, and large, we set it to a few minutes. And also we have the RTT from institutional router to the server. So this is 2 seconds. And 2 seconds plus the queuing delay, large. So it's minutes. And also lane delay, it's really small, so it doesn't matter. So this is a current setting. We have a scenario like this. Well, so for this one, how to have the enhancement. So let me erase all and check the others. We have the queuing delay because of high traffic load here. So this is the bottleneck. Right? So right now we want to have the changes to the network setting. So same for this. And same for this, same for this. So likewise, same for this. But where we change, so this one, the current one, the previous one, same. So up to now, the same. This is the previous setting. But we change this one to 154. So here. So we will correct this one to this version. All right, that's good. So right now, the queuing delay reduced to really smaller one. So smaller one, we change it to milliseconds. All right, so it tax effect, no problem if we can have the fattest links. The fattest links, and then we need to pay more. So this one, maybe it should be an expensive solution. So should we use it? Maybe no. So you see, expensive. All right, even we can reduce the time to the really smaller one, but it's expensive solution. So should we use it? Later we can have a different solution. So you can think about the new solution, okay or not. So let me have the story for this. This is the original version. At this, if we have a large queuing delay, more than a few minutes. If we have the fattest links, and then we have the time, maybe around 2 seconds. Well, the current one, we have the new setting. We don't want to have the fattest link, and we want to have the installation of a web cache. So we want to install a web cache. So up to now, same, 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 and same, and same. However, how about we have a cache here? So we will have a cache. A cache, something like we can have a server. Right? So of course, it will be cheap. If so, how to have the following utilization for LAN access link, and so that how to have the end-to-end delay. So let us have the calculation for you. How to compute. So to have the computation, we should have the further information. Well, assume hit rate is 0.4. And so that we will have 0.6. So we will have 0.6 of a request to go through. Well, so right now the request rate reduced. So from original 1.5 to the current one, 0.9 only. And so that the utilization will be this one, 0.6, approximately 0.6. Well, the traffic load has been reduced. And so that we have the calculation. So let me erase some of the derivation up to now. So the delay, it should be hit ratio. So satisfy at cache and LAN delay only. So almost 0, so it's 0. And the delay from the client to the server, but the load rate or traffic load to 0.58. So what is the delay for 0.54? Previously, we assumed 0.95 is minutes. And how about this one? Actually, we assume it should be this. We assume it should be a few. For example, just 10 milliseconds. Well, from 1 millisecond to the current one, so this is assumption. Because we have the curve. Queuing delay. And here it's 1. So we assume this one minutes. And this one 10 milliseconds. Or maybe you don't think so, it's 100, that's okay. And here, maybe millisecond. All right, so if so, then we have the results. The delay should be 2 plus 10 milliseconds plus 0 for the others. All right, and here this one is 0. And so that we will have the results. The result, it should be this one. So this one, okay, it's true. So finally, we have this equal to 2.01 seconds. So that's why we have this one. And also this one is 0. So finally, we have approximately 1.2 seconds for the new version. If we have the assumption of 0.4 hit ratio. All right, so previously we have the time approximately 2 seconds, a bit more, and currently it's 1.2 only. So this one, even it's a cheaper solution. However, we have the smaller time possibly. So this is the current version. If we install a web cache, it seems to be becomes even better, right? Even better. However, maybe you have a question. We have the assumption like this. And actually based on the curve. So maybe you don't think it's reasonable. You want to change it to 100 milliseconds. That's fine. Even 100 milliseconds. The current end-to-end delay lower than the previous 2 seconds. All right. Okay, so this is assumption, and the assumption is given in the taskbar. It doesn't mean I directly have the assumption or the story like this. You can check the taskbar, and so that you will know, yes, it's true. The authors in the taskbar assume it should be around 10 milliseconds. When we have a traffic load approximately 0.6. So given the assumption, then we will have the value here. And so that you have 1.2 seconds for the end-to-end delay. All right, so this is the derivation for the case to have a web cache. So up to now, we have the solution. First one, faster link. And second one, web cache. And of course, the original one, no cache plus slower link. All right, compared to the original one, no cache and slower link, then we will have the better solution. Based on the current end-to-end delay, which one better? This one. So cheaper and faster. All right, expensive for the first solution. But we call somewhat faster. Right, why I have the extra term somewhat faster? Because 2 seconds larger than 1.2 seconds. So I have the extra term to denote the current speed. It is somewhat faster, but it doesn't mean really faster. But for web cache, we can have the shorter time, so we have faster only. And the faster only to indicate, yes, faster than somewhat faster. Well, this is somewhat like the summary, but the summary that I have the solution, web cache better. So if we have a scenario, a client and proxy and original server. All right, and actually I didn't have the question. Even Previously I set it to the activity, but I don't know if we have online courses, we won't have the activity. But I mentioned the question for you. And here, let me pose the question. If we have a non-zero hit rate, all right, and delay for objects will be reduced. So the question is, if we have a non-zero hit rate, and I ask you, delay for all objects will be reduced. So let's check these. In fact, the answer is yes. Yes for all objects. All right, yes and all. Why yes and for all? So we have the comparison. Client here, proxy here, and original server. So think about if hit. So of course reduced because of almost zero. All right. If not hit, so here reduce. So think about this, because if we have a hit and not hit here, so we have the reduced request rate. To the original server. Right? Reduce request rate to the original server because of non-zero hit rate. All right? Because of a non-zero hit rate, then this one we will have a reduced delay. Right? So case 1 and case 2. For two cases, actually, the two cases can have the reduced delay. So all object. So based on the two description, all object will have the reduced delay. All right, so I emphasize all. So this one is really important, and that you have this to think about. Is it true? All right, so for this one, you can think about, is it true? For the current one, maybe that you have 2 minutes to think about this. All right, so think about this one, and also let me go to the restroom first. Okay, so time's up. Let me emphasize, we have all objects to have the reduced delay, not some. All right. We have the two reasons. Reason one, if we have the object heat, all right, then we have the reduced delay to really small end-to-end delay, but not heat. Why we still can reduce the delay? Because we have the reduced traffic rate to the original server if we have the non-zero heat rate. Because of the two reasons or two cases, and two cases can reach, all objects will have the reduced delay. So finally, we have the conclusion for all objects to have the reduced delay, rather than just some. No, not some. It should be all. All objects will have the reduced delay. Even originally you don't think so, but if we can have the two cases to examine the results, you will understand the answer is yes. All right, so that's why I didn't have 2 minutes to think about this. And I think it should be okay. Then let me move on to the next one. And about this, because I promised no activity during the online course, so I skipped that one. And next one, we have the conditional get. Conditional. So you should know the term conditional. It says don't send the object if cache has up-to-date cache version. All right, don't send. That says if we don't have it, then don't send. So we will have the condition. Specify the time. So you see, if modified, then we will do something, or otherwise, yeah, nothing new. So the server response contains no object if the cache copy is up to date. All right. So here it says, okay, to get, we know. We talk about the process, so we know nothing new. So nothing new. Currently nothing new, so it won't be used to send to the request. So this is a conditional get. So you see, we have a client. Okay, so if modified, then you do. Okay, object not modified. Because not modified, so not modified to the client, no request. So the client here can be proxy for sure. Because proxy can have the role of a client. So here it says, I have the copy. The client has a copy, so it won't be necessary to receive it again. So the server will use this if you have the condition. Because I have it if you don't modify it. So yes, don't modify, then it won't be necessary. However, if a few days later we have a modification, so we will send the data along with the response. So this is a conditional get. Okay. All right, later we will have the further discussion. All right, the further discussion talking about HTTP version 2. Previously, we talked about version 1 and version 1.1 specifically. And for version 1.1, we can have multiple objects. All right, we can have pipelining if we consider persistent. All right, so we consider persistent. And persistent here, in fact, we have a pipelining. All right. So persistent with pipelining, it's a version of 1.1. So you can see we can respond in order. That's correct. However, it should be first in, first come. Oh, sorry. First come, first serve. With first come, first serve, you see, small object have to wait transmission. Wait transmission here we call maybe a larger object before the small object. So we should wait. And this kind of waiting we call head of line blocking. Why it's blocking? It doesn't mean totally block the current transmission. It says waiting for a long time. So we have actual waiting and longer waiting. So we have the head of line blocking. Let me mention this again. It doesn't mean totally block the current object. We should wait for a long time for the small object. You see, behind large object. And if we want to have the recovery, that says retransmission. And same, or stall the object transmission. All right. Because of that, we want to have the beta version. The current beta version, we want to have all of the previous features, but we want to have some changes. And so that we can have the transmission order, but we want to have the changes to smaller for divide the object into smaller frame if necessary. Divide the large object. Here it should be large. So let us have the illustration like this. You see the original problem. HTTP2, we want to mitigate the HOL blocking. So we assume we have a large object first, and then smaller object. So large. And of course, we should wait, and wait. If we have the in-order delivery, then object 2, object 3, and object 4 should wait the transmission delay of a really large object. So this is a problem. And how we solve the problem? We try to divide the large object into smaller frame. Currently, the frame, it doesn't mean the frame in the data link layer, but at least we have the new name different from the current objects. So we have a term frame here. Frame means the smaller object. So we still have the order 1 first, and then 2 and 3 and 4. If we can send one frame from the large object. So we have this in order for sure, but one after one, then we have 2, 3, 4, and we can repeat the transmission for object 1. But here it says we can have the possible transmission 2. Maybe you think why it's 2 and 4. All right, and then 3. Perhaps we have some assumption. Even it should be 3 and 4, fine. And here it says maybe we allow 2 to transmit it. Perhaps we use random order among 2, 3, and 4. So that's why we pick 2. So it doesn't mean 2 and 3. This time we pick 2 and 4. So because of 2 and 4, so we have this. And we have a 1 again, so we have a 3. And so that we can finish the transmission. So object 1 will be delayed slightly. Extra delay with a slight extra delay. Well, if so, we can mitigate the HOL blocking for object 2, 3, and 4. All right. Well, actually, we have the migration from version 2 to version 4. And likewise, we want to have the beta performance. And we have the security. And also, we have error control. We have congestion control in HTTP3. And you should understand no security for vanilla TCP. And so that no security for HTTP. Even later, we have some enhancement. All right, so enhancement specifically in version 3. All right, so that we will have the further enhancement in version 3. But currently, we don't know simply, and we won't pursue the details for version 3. If you are interested in HTTP version 3, you can check it. And last one, data check it further. Even we finish the discussion for the part web and HTTP. So this time, data check email. Email, I think, it's easy for you, right? But we want to know some of the protocol association. So we have the possible association of protocols. For email, I think it's easy, we have user agent, UA. And we have a mail server, for sure, we have the mail server. But we should have a protocol. And this kind of protocol we will call Simple Mail Transfer Protocol. So we have SMTP. SMTP, normally SMTP among servers. And also SMTP related to client, actually the user agent, sometimes user agent. But normally SMTP to transfer the mail among servers. And later we will have a bit to talk about UA related to SMTP for a bit. So UA, also known as, aka also known as mail reader, it's reader. It can allow you to compose, to edit, to read mail messages. For example, you can have Outlook, you can use your iPhone, you can have the others. And of course, for messages, it will store on the server. And we want to get that one from the server to read and to send it to the server for the forwarding. So this is a user agent. And also we have the description for the server here simply. And server, actually we have the mailbox to contain the incoming messages for users. And of course we will have the message queue of outgoing to send. All right, so the message to be sent. You see, SMTP protocol between mail server, two mail servers. Actually, 2 mail servers. Previously, I didn't know, SMTP will be optional among SMTP server. In fact, specifically just between the 2 mail servers. So I will send to you, send to me, and the others. And of course, if I want to get the mail, all right, so we will transfer So we have a transfer. Using the term transfer, then this is the real functions of SMTP. And actually, talking about email, we will have a standard. It's RFC 5321. So for email, of course, we should have a TCP because of the reliable transfer. And the port number, server port number, it is set to 25. And we will have the direct transfer. We will have the procedure. Handshaking that says greeting to establish connection. Right? And then we can have the transfer to transfer the messages. After that, we close the connection. And we draw your attention to know all the comment or requests or the response interaction similar to HTTP request response. Right? So similar to that one, we can have the command and response. And similar to that one, all in ASCII text or ASCII code. We will have the response in status code and phrases. Right? All in ASCII, 7-bit ASCII. Well, this is a scenario of sending an email, but I think time's up. So I stop here, and this Wednesday, we can continue. And I try to that it have the possible content, reasonable content, and I think you can check them. And don't forget to check them, or otherwise we will fail to know the content for the two classes. All right. Normally I should ask you the question, but because of online, I won't ask you the question. So that's all for today's two classes. That's it, and that's Korea Day, and see you this Wednesday. Bye-bye.